Okay. Hello, everyone. Yeah, so it looks like we are up and running. Let me check. Yeah, sound is good. Everything good. So we are back on our playground, trying to solve some Rust problems. Yeah, the plan for today is to solve the problem of the day. I didn't manage to solve it during the day, so we'll try to solve it. After that, we'll get back to our bit manipulation problems. So we'll be continuing with that part. Yeah, checking if we're good on the client device as well. Okay, so are we up? Are we good? Yeah. Yeah. So let's see what's up with this problem of the day. Least number of unique integers after key removals. Okay, so given an array of integers r and an integer k, find the least number of unique integers after removing exactly k elements. So we're given an array and we need to remove items from this array in such a manner that find the least number of unique integers after removing exactly k elements. So we need to reduce the amount of unique indexes. So this would mean we need something in the form of we need to find which are the most frequent and try to sort them by frequency, I assume. So yeah, let's play around with a couple of examples. So I'll do my screenshot. Let me copy this too. I'll paste it here and try to brainstorm a bit. So let's try to go with the first example. So we have a vector, we have a couple of items like 5, 5, and 4. If we do a frequency map, we'll have like 5 being 2 times and 4 being 1 time. So this will be like a frequency map and k1. So if we remove k in our case, so let me switch color. So probably let's use k equal 1. So in our case, we see here that we need to kind of remove 4 or 1 in this case, and we'll be remaining with 2. So what exactly output 1? So if we are removing this, we need to count how many remains, because if we're removing this part, we need to count how many items remain in this set. So in that specific case, it remains only 5, which will be 1. That's quite interesting. If we go back and try to work on the second example, so let's try to see what do we have here, like 4, 3, 1, 1, 3, again 3, and 2. And we need to remove up to k elements, which will be 3 elements. So remaining will be 2. So let's do again our map of items. So we'll have 4 again being 1. We have 3. So we have like 3 freeze. 1, it's 2 times. And 2, it's how many times? It's 1 time. So if we try to sort the frequencies, we'll receive like a frequency where it will be like a 4 with the frequency 1, then we'll have 2 with the frequency 1, then we'll have 1 with the frequency 2, and in the end we'll have like 3 with the frequency 3. So we need to remove, if I understand correctly, the least frequent. We need to remove like starting this one. So can we remove it? Yes, we kind of can. Can we remove this? Yeah, we can. Here we have 2 of them, but if we remove this 2, k minus 2 will be remain 1, so we'll be able to remove only 1 out of this, so still 1 will be remaining. So the end result will have like 1 ones and 3 threes. So I guess that will be the output 2. Okay, so kind of we have outlined an algorithm. First stage obviously will be to find the frequencies. This can be one way to go. Second stage, we'll need to sort the frequencies. And third stage is to do the removal, and fourth stage will be to kind of wrap everything up and try to find a solution. So if we go with this approach, like finding frequency will be big O of n, so this will be like time complexity. Sorting will be like big O of n log n. And again, traversing, finding, removing will be a big O of n. So the time complexity of this algorithm will be big O of n log n. So the question is, can we do it in a better way? Because we kind of need to sort a very specific amount of values. So this array of ours, it's kind of have some boundaries. So there is this concept of a bucket sort. So I've learned it from LeetCode. So often I check his solutions and got inspired with this approach. So bucket sort will be the idea of sorting the values in a linear form. How can we do that? How can we sort something in a linear way? The idea is that we will create a very specific vector, and we'll know, for example, that we'll find the frequencies, but what we can do, for example, we know that but actually maybe we will not sort necessarily them, but actually we will. So we will just need to count again the frequencies, and having here, so for example, for index 1, so let's assume we have index 0, will not have, but for index 1, how many ones do we have in our system? So here we have like 2 ones. How many 2s do we have? We have only 1 2, so this is the 2 part. So we'll have only 1. How many 3s do we have? So here will be the indexes. So it will be like 0, 1, 2, 3, and then we'll move into 4, 5, and so on. So 3, we have like 1. Kind of first stage, what we do, we count the frequencies, but second stage, we don't actually need to sort them in one way. Or to be more precise, actually we kind of need to, but yeah, so probably I'll need to think a little bit more on the idea. But the idea of a bucket sort, it's we have a bounded vector, so we have like a vector which we know the values, so we may be able to put the values in the right indexes and them to being already in a sorted manner. But specifically for this case, I think I didn't go onto the right path, so we'll need to play around. Okay, so first assumption, we have I just want so I guess, yeah, the goal will be to have an algorithm which uses big O of n time. So in this case, yeah, we did the frequency. So first stage, count frequency. Count the frequency. So we did that. Let's imagine we implemented this part of the code. So next stage, we kind of need to sort together okay, so it's 3 being 1. Yeah, here the math may be a little bit problematic. So this means like we have 3 3s, or oh, kind of I got it. Yeah, so that's a good approach, because we will just need to update a little bit on the math, but they will be sorted in this case, because we'll know the values right away. They will be in increased order. So for example, ones, 2, 3, 1. So fours, we have only 1, 1, 4. Or actually fours we don't have any, because we are counting only this. So we have 2 ones, 1 3, and 2 again 2, yeah, so once we counted them already. So these are the values. So like we have 2 repeating values of 1. Yeah, that's the confusing part for me as well. But that's interesting. Okay. Yeah, probably we should start writing some code and we'll get from there. Yeah, let me create okay, so cargo new lib list number of unique integers after k removals. List number of unique integers after k removal. Code list number Okay, removal. We don't need this, sorry, for the eyes. Okay, so we are in VS Code. Yeah, let's add our solution and some and the unit tests and start solving this. So here we'll be writing a to-do for this to compile. We'll need to create our solution, and let me disable Copilot, because we don't need to cheat during this problem. Okay, we have this here. It works. Scenarios. Let's add a couple of scenarios. So we'll need a vector, a value. Second one will be like another value. Here we'll have like solution, and that would be call. So we'll have our vector or array and k. And let's call it with array and k. So yeah, we defined our scenarios, our tests. Now let's add this too. So this will be a vec. K will be 1. And the output will be 1 for this scenario. Next scenario, let's go back, copy this part. This time we'll be removing like 3 elements, 3 items. And the output should be like 2. Yeah, unfortunately, we will need another example. It auto lints it and formats it, but I don't like the way it do. Maybe I should add a comma. Okay, wherever. So this is Rust doing, not my doing, guys. So okay, so we defined our test cases. Let's run. At least it compiles. Definitely it will not work because it's not yet implemented. Yeah, let's write first. But I'm thinking, do we actually need to? Yeah, kind of will need to find the frequencies. So yeah, let's find the frequencies. So we can do it in this form. Probably. So I have 2 options for this. First option would be to use a hash map. The second to use a vector. Both of them are viable. Both of them work fine. Vector usually, if it's a fixed size, uses less space. But let's start first with the hash map. So let's fold it, provide the hash map. New. We'll have our mutable accumulator, and we'll have our item. So we'll have an entry. Which will be accumulator.entry.item. Entry or insert 0. We need to define it with a default value, which will be 0 at first. And now we'll need to increment this value by 1. So that's the simplest idiomatic way how we can count the frequencies. Second approach would be like to look at the constraints. So we know that the array length will be like 10 of power 5, which means like 10,000. The other way around, we can create like a vector. We can do it in this form. We know that it's bound to be 10,000 max. So instead of a hash map in this form, we can do a vec of 0, 10,000. So in this case, we'll not need to do this part, but no, actually, if we want to go this way, I wanted to use an index, but the values of the array will be 10 power 9. So yeah, this is not a viable solution because it's not 10,000 here, but I'll need to write like 10 power 9, which will be too much. Because what I plan to do is increment the index, the value at the index item, which will be not very smart thing to do. So yeah, let's get back to our hash map. Okay, so we do have our frequencies. Next stage, we kind of need to sort them. We need to sort the frequencies. Yeah, you're right. Yeah, Alex, you're right. But still, yeah, 100,000 is too much to allocate. It's not a smart thing to do. Yeah. By the way, welcome aboard. So I do streams on solving problems from LeetCode from time to time. I try to improve my algorithmic skills. So yes, solved a couple. Good. So yeah, first stage we do have our frequency. So yeah, this we did. Next stage, out of those frequencies, we kind of need to sort them. But I do not want to use a normal sort, like a quick sort or something. I just want a quick sort. I just want to try to use a different technique in order to use this approach to have a linear time. So yeah, actually in this case, yeah, here we can use this approach, what I mentioned above. So it's this problem kind of have like 2 layers or 2 levels of let's say counting frequencies. So the second stage, what we can try to do, it's once we have this part, we will know the indexes and how many values, but I still didn't figure out how this will help me. So let's assume we've got this. So we've got our index, index 0, nothing, index 1. There are 2 items, index 2, it's 1, and 3, it's 1, and everything else will be zeros. So let's assume we've got to this stage. Is it enough for us to find a solution? So here we know that k will be equal to 3. So let's assume we've got we go one by one in order. Let's assume we have this pair, and this mean we'll need to look at this value. So k minus 2. So we'll be removing 2 of them. K will be 1. K will be 1. So we go next because k is not at empty. But yeah, that's a little bit tricky though, because we kind of need to do not k minus 2, the k minus value at the index multiplied by index as well. So if we go with this formula, we'll have like k3 value will be 2 multiplied by index 1. So then we'll have a k remaining to 1. So if we go next, it will be like k minus 1 multiplied by 2, because we have the index being 2. So k being 1. So actually this in modulo or absolute value, this means that we will remain 1 here. So probably we'll need to switch back and put 1 here, but that's too complicated. Yeah, I'm not sure if that's the right path to go. Maybe we should figure out another approach, because this bucket sorting maybe it does work, but in a weird manner. I think I can try to make it work though. Yeah, so I guess if we go with the simplest approach, now to just sort it. So let's assume we go with a super simple approach. We've got our distinct values. So we'll have our frequencies. Probably we'll not even need to play around with the values anymore, because they do not ask us the values. So we'll have like 1, 1, 2, and 3. So this being our values. But if you do write them in this form, probably we can make it work though using this formula. Yeah, I think we can make it work. So k minus value multiplied by I. I guess in absolute value. So we'll be extracting as much as we can, and if something will remain, though I'm not sure how to mark it though. How will be marking this? Because here will remain 1. Maybe if we mutate it, so if we remove 2 out of here, if we do the removal part, then 2 will be 0, because 2 will become 1. So we'll have a 1 value here, and k will be 0 in this case. Yeah, k will be 0. So if we count again how many items do have values, it will be how many like items have something inside here. Could be 1 or more. Oh, hello, hello, Night Emperor. Welcome back. I know your nickname, though I forgot where you're from. So there are a couple of options. So it's Sri Lanka, India, or Turkey. So one of the free options, because I remember when speaking with the peoples with people from those parts. Okay, got it. So yeah, let's try to write the second stage of this, like this second counting, where bucket sorting, if we can call it this way. Second option, India. Okay, so second was India, if I'm not mistaken. Okay, so we have frequencies. Out of frequencies, we need to find, yeah, frequencies of frequencies. Probably we can call it this way. Not sure if it's the right way to to go. Yeah, let's make it mutable, because for sure we'll mutate it in the next stage. So again, we'll need to go through frequencies, though in our case it will be only through values, and we'll need to, yeah, we can do an into iterator, that's fine. Here we'll be folding, we'll be sending in this case. Yeah, the question is how big should be our vector. So yeah, let's look at the constraints in this case. Oh, hello, hello, good night, good night. Yeah, it's quite late in India. I'm not sure what you are doing so late. So, good night, sleep tight. So we have the array length being 10 power 5. So this is 100,000s, not 10,000s. So my mistake. So probably we should bound it to 100,000s, which is quite a lot, but what else can we do? What does it mean though? So this means we may have like the same item repeating 100,000 times. So that's possible, and this will be like the last value in our vector. So this one, and we'll have the value 1, which is quite interesting and tricky. So yeah, let's bound it this way then. Fair enough. So we'll have 0 here and 100,000. So next we'll have our mutable accumulator, our item. Then we'll do something is not right here, not sure I got it. Okay. So now we'll have the index being item, so accumulator at item, but this is an U32, so probably values will not be I32s, but I can do easily an U32, because we'll be incrementing them by 1. So here we'll have item being U32, so item as U size, but we'll need to dereference it because this will not work, and we'll need to increment by 1. So we'll be returning that. So second stage, we've finished to write the code. So we have the frequencies of the numbers. then we have the frequency of the frequencies. And next stage we'll need to do the manipulations on this vector. We'll need to do the manipulations because we have k. So I guess the algorithm will be like while k is greater than 0, because we need to do operations till k is greater than 0. Or not like that though. Yeah, kind of will need to go item by item. In frequency or frequencies. So we'll go this route. But we will need as well the indexes. So we'll need to enumerate them. So we'll have the indexes. Okay. Okay, so now we'll try. So let's assume we've got items. So yeah, let's go back to our drawing board. Let's go back here. So let's assume we've got our vector here in this form. So we've got 0, 0. What happens when we've got 0? Nothing. If it's 0, we don't do anything, we move on. If it is a value greater than 0, so let's assume it's this tuple, like 1 and 2, then we'll do our computation to remove k. So k will be minus equal to, or this formula of 2 multiplied by I, or value multiplied by index, which will be 1 in that case. So k will be equal 1, remainder of k. But if this was successful, then we'll need to remove it completely from the array. So index 1 will become 0 in this case. So let's go back. So 0, 1. So here we'll have 0. Next one will be 2, which will be 1, 3, and 4s. So this became 0. But k is not yet empty, so we need to go next item. So next item will be 1 at index 2. So what's the formula? K minus 2 multiplied by 1, where actually in this case it will be 1 multiplied by 2. So this means k goes out of bounds. So we may do the assumption that this is too big. The subtraction is too big, so we need to subtract till it's 0. So some sort of remainder. So remainder will be 1, because k will be 1, so we'll be removing one item. But in this case, if we remove one out of this sum, that's the tricky part, because I'm a little bit... where should we write it, though? That's the trick. I'm not sure I can define a formula where to write it. Because yeah, we know that this formula, like 1 multiplied by 2, will give us 2 items. But if we remove 1 out of these 2, and it will be like 1, where this 1 should go? I guess should go into at index 1, so we'll be incrementing this to 1. Yeah, probably that's the case. Okay, yeah. Interesting one, though. Interesting problem, what can I say? So we can try to write this part. I'm not sure if we really need it. I mean, I just wanted to check if okay. But yeah, probably I should do like index and value, because that would be easier to follow. So if value is 0, we just continue. So that was easy. Next step, if it's not 0, we do our logic of removal. We try to remove k minus equal index index multiplied by volume. So this is the formula. But we should do some checks. So first check, I guess we can write something in this form. If k minus index multiplied by value greater than 0, this is an easy step. This means we do k minus equal index multiplied by value. Unfortunately, this doesn't work in Rust, because we have 2 different types, so I'll need to cast either value or index, but probably I need to cast value to an i32. Not value, I need to cast the index part for this operation to work. Yeah. Hello, frontman. How's life? I don't recall your nickname though, so where are you from? How did you get to Rust and this problem solving? Okay, so yeah, we did stumble upon this. Why don't you like? Okay, so this should be mutable. I guess like let mutable k. So we'll do a copy of this. Hello. Welcome. So hi, hello, Ganesh. Welcome aboard. Today I'm trying to solve this problem: least number of unique integers after k removals. So I had initially an idea on how to solve it using a sort, but I do not want to use like I don't want to have n log n algorithm. I just want to have big O of n solution. So I'm trying to write it down mid-semester exams. Oh, I remember you. Yeah. So we had like a cool discussion. Yeah. Welcome back. Pretty cool that I make new friends. Yeah, so I've written this part. So if it's greater than 0, so first stage we remove items from k. Next stage we'll need to clean up the frequencies at item index will become 0 because we use them. Okay, I'm not interested in coding, Alex. Which courses should I learn? I'm not interested in coding. Which courses should I learn to get non-tech IT jobs? Non-tech IT jobs. Okay, so you want non-tech. I guess you should try like Scrum or Agile certifications. Some team have like this sort of agile structure and they use Scrum, and there are opportunities for more like management positions or sort of management positions. It's not like necessarily or exactly management positions. So you can try to make like an agile certification. That could be useful if you do not want to go tech. But IT, it's tech. Either way, it will be tough to have like a career without completely ignoring tech stuff. So you'll need some basics. So still you'll need to deal with tech. But yeah, go on the management path. So trying to define projects, do estimations, calculate cost structures, buffers, estimates, and so on. So that could be a way for you to go. Okay, so we've got this part. Now we'll need to handle the second part, where where k goes out of bounds. So I guess this will be that case. If this will be the case, then we can mark right away k being 0, but no, that's not a good approach. We need to find the remainder, and this will be like index. Yeah, that's ugly as hell, but I'll try to refactor it later on. Minus k, because we know that this is bigger. So we have our remainder, and then we'll just do accumulator at index minus equal how much. No, actually not this. Is it possible though to remove 2 and have 2 again? No, it's not. So accumulated at remainder, let's increment to 1. And k, let's make it 0. So we've got here, yeah, probably shouldn't remove this. What don't you like? Yeah, we don't have accumulator. It's frequency of frequencies. Yeah, this is what I was afraid of. To do a clone. probably we should do a clone. Yeah, the trouble here. Where do you code? I don't understand any of that, but I'm interested. Where do I code? Do you mean where do I work? What's the tool that I use? This editor? If you want to know the editor part, that's called VS Code. So it's a very popular editor. Pretty much everyone uses it. Yeah, so I mean everyone from my friends. Yeah. Okay, so the editor, it's a VS Code. So if you want to get it, so simplest way is you can go to VS Code. I think it's the site. So Visual Studio Code, code editing redefined. So you'll download it. And thanks. Yeah. Okay, so let me think how we can deal with this part. Maybe I should go with the iterator. But in this case, I'll need to destructure this and cannot borrow as mutable because borrow is immutable. That's one way. Second way, we can do a clone. That's so ugly, but I mean that's how Rust works, unfortunately. So let's clone frequency. So frequency or frequencies dot clone. So what I'm doing here, it's a tricky concept of Rust, but Rust doesn't allow you at the same time to traverse a vector and mutate it. And this is a constraint which solves many tricks and bugs, like with dangling pointers, and also helps you with concurrency, because I can do like parallel iterations, but unfortunately I cannot edit it. So if you're coming from JavaScript or maybe even Java, definitely you can do a for each loop and do manipulation on the same vector or array, but not here. This is not allowed. So what I'll be doing, I'll be traversing, but the manipulation part I'll be doing on my clone frequency vector, because this will be mutable. And this will solve the trouble. We'll be kind of traversing what's your programming area? I do have a couple of years of experience, so I'm a backend software engineer. Yeah, thank you. Yeah, I try to learn and improve. I mean, this path of coding, it's quite long, and I started like in I had like 15 years ago, no, like 20 years ago. So 20 years ago I started coding like PHP, but I do work in software engineering, like a professional software engineer after I did my university and stuff for 11 years. So this will be my 12th year as an engineer. So currently working for an American company in clinical industry, and we do clinical trials there. So as I used to be a team lead, but I stepped down from this position because I burned out really badly. So now I'm just coding, so enjoying the joy of solving problems and coding. Yeah. Okay, so we did this. I don't know if that's an idiomatic way to do it in Rust, though that's my workaround to solve it. So if I understand correctly, we can do some debugging. So let's print our clone frequency and see the results. So yeah, let's check. So we'll be running our tests. Unfortunately, it's a huge one. So for the sake of debugging, I'll just use like a 10 for us to be able to understand what's going on. So yeah, this will be like first. This is the first test case or second? I think it's first. So we have like I'm sure I got it. So yeah, let's run it with the debugger. Yeah. Your dream is to become a hacker. Okay, kind of. I'm not sure if it's in the chat, but there was a guy from India, frontman. He has exactly the same dream. Exactly. He also wanted to become a hacker. And to be honest, this is how I started coding. I also initially I wanted to become a hacker. So yeah, hackers are sort of software engineers, but not necessarily. They specialize in security mainly, and it's a little bit different path, but not necessarily more paid or better paid than software engineers. So I personally would not go again on this path, because software engineers, if you're a good one, you'll have a lot more than let's say an ethical hacker, so or a white hat hacker. Because white hat hackers, I mean people who work in companies, what they do pen testing or penetration testing. So they receive from some clients the request, okay, hack my company website, infrastructure, whatever. So the white hacker will be trying to hack it, and at the end he'll be writing a huge report, a document with all the vulnerabilities and how they should be fixed and so on. And this is a lot of paperwork. Maybe it may seem like it's being cool at first, but it's a lot of documentation you'll need to write down. So sometimes it's boring. But if you enjoy that, it could be cool. But yeah, TV series they are more romantic than the reality, so nothing gets that easy or that cool, or hacking being that cool. I recall on my youth, I had like a thought. I want to become a hacker to pick up girls. So this is kind of an insane thought now at 34 years, when I'm 34 years old. Because if you want to become a hacker, you'll really need to spend tons of time studying, and you'll not have time for girls at all, and your skills to pick up them, they'll be like zero, non-existent. So if you have same thoughts, then that could be disappointing at some point. Okay. Yeah, so let's go with the debugger. So we've got here, we don't care. We need to get here. That's where we do care. Let me check the values. So we've got frequency of frequencies, assumption, so it's 2 1. Okay, that's correct. Yeah, I am a hacker to some degree. When I was younger, I did hack a lot of stuff. I used to, nothing illegal, but try different things. And it's not my path though. For sure, it's not something which I would like to do. I don't like the stress of being caught and stuff like this. It's too difficult to live this way. Okay, so yeah, let's do this. So looks like y. Okay, 1. Okay, yeah, this is index 1, value 1. Yeah, probably we should include here the value 0, because we may remove just enough and then it will be good. So yeah, let's go back, try again. Yeah. A reminder. Okay, 0 in this case. So why do we? Yeah, but it's equal to 0. Wait, this doesn't make a lot of sense. Is it greater or equal to than 0? How did we get there? So this is 0, this is 1, this is 2. Wait, something is not right. Okay, something is definitely not right, because this is a negative value. If k is 0, yeah, if value, yeah, probably we should use something like this and just break. Because I don't want to cycle around. So k, it's 1. That's fine. We do this, we remove. It's 0, we break. So what's the clone? It's 1. So cool. Next stage, we kind of need to count. We'll need to count. So clone frequency. We'll be filtering. Yeah, we'll need to iterate it first, of course. So we'll need to filter x greater than 0, and then we'll need to count and return an i32. Yeah, that's a little bit sad. But we got that. Okay, let's run it. Did it work? No. Side 32. Let's check. Okay, so scenario 1 did work, though scenario 2 did not, because it was yeah, let's debug a little bit scenario number 2. To try to understand what's going on. Okay, so finally it did what I've requested. Okay, so frequencies we've got, this part we've got, so let's check the values. Yeah, it's the ones which we looked at. Now we have this part, we have k being 0, we did this operation, we remove, so we removed from clone. Next operation, it's index 2. Okay, it will be like 1 in this case. K is not 0. We go to the reminder logic. Reminder will be 1. Clone frequency plus 1, so I'm expecting... Oh, yeah, I understood the bug. Yeah, so clone frequency of index will become 0, and this will be incremented because we were double counting it. So now it should work fine. Yeah, so our tests are working fine, both of them. So kind of we got to the solution. It's quite ugly, but I would like to test it on LeetCode first, and then if it works fine, let's try to refactor it a little bit. Okay, let me remove this. So we don't need this part. Let's check first if this build doesn't work. Yeah, this part it's okay. Let's try to submit it. So we have a wrong answer. Output being 2, but expected to be 3. So it looks like we have a problem in our logic. Yeah, let's check. Let's add this test case, that being the test case. So these two, we know that they are working fine. Let's try to see what's up with this one. Okay, so expected, wait, output is 2, expected to be 3, and k is 3. Okay, so k it's equal to 3. Fine. So let's run it first. Yeah, indeed, it's not right. Sure, yeah. Hey, Toa. Sure. I mean, I'll be for quite a while, because, yeah, you know, when you do TV shows, hackers do everything very fast. Unfortunately, in real life, it's not like that. So you may spend like hours and hours to solve a problem. So you'll not feel like a hacker during that time. So, so that's the reality, though. Once you'll hack something, it may take a while. But yeah, thank you for joining in. So yeah, waiting you back. If you have any questions, we'll gladly answer everything. Okay, so we've got here. So I guess we may have troubles with this logic. I have an intuition that here we may have some troubles. Let's try to go with the debugger and see what did we got. So frequency So we have 4 elements 1. Okay, I'm not sure I understood where these values come from. Yeah, let's try this specific scenario on our whiteboard. Because I'm a bit confused. I'm not sure where did they come from. Okay, let's copy this part. Yeah, looks like I zoomed it too much. Okay. Yeah, probably this will be good enough. God, where did I put my pencil? Yeah, it's here. So, first stage, doing the counting part. So 2, 1, 4, 1. Okay, so kind of got where did they come from. 1, 2, 8, 1, 3, 2, 5, 1. So we've got position 1, 4 items. What else do we have? 2s. We have 2 items. Position 2, we have 2 items. So it's 0, 4, and 2. And k being 3. So if we remove I think my logic of summing them up, it's not right. It's distinct. Because I need to sum them up. Yeah, I think I got it now. This part. So I don't need to count them, I'll need to sum them. But probably in this case doesn't matter this part, so I'll just need to sum. And I don't need to do this because it's already let's see, cargo test. Okay, yeah, I'm not sure. What did it do? Okay, so one test is working. So that was the problem. Yeah, let's check everything now. So yeah, all tests are working. Yeah, that was the trouble. So yeah, let's copy this, go here, change this line, run again. Try to submit. Yeah, we have another wrong answer. Okay, 1, output being 1, expected to be 3. Yeah, let's add this scenario. Not sure why this doesn't work. Okay, 1 and output being 3. So yeah, let me try to take a screenshot of this part. Ayushman Thakur. Hello, hello. Yeah, welcome, welcome. Please give shout out. Sure, hello. Shout out to Ayushman Thakur. Sorry if I'm butchering your name. So welcome. Welcome. So yeah, let's fastly go through this example. So 1, 2, 2s, 2, 3, 2s, and we've got here 1. Wait, so if we go this way, so we have like a 2, 0, 0, 0, okay, so position 0, 0, 1, and 2 being 3. No, you're totally correct. Ishman Thakur. Okay, good. Yeah, welcome aboard. So yeah, it is an interesting case because we know that by applying this formula of ours, unfortunately this formula of ours, it's a little bit tricky. This means like we have 3 items by 2. So this means we'll have, if we draw like 2 points, and then another 2 points, another 2 points, so this will be like 6. So if we remove one of it, it will remain like k. But k, it's 5. What does imply 5? It implies that this 2 will remain the same 2's. So if I receive 5 in this case, but yeah, 5 it's formed by we kind of need to do 5 modulo 2. Yeah, this is a little bit more complex than I thought. So so we'll need to mod it. We're actually not mod it, but divide this to the value, to the index, and we'll be receiving like 2, and the modded value, it will go in another vector. So we'll have 2 here, and 1, the value 1 will go at the index 1. So something on those lines. Yeah, that's pretty insane, to be honest. If you want to make a small optimization, things get exponentially more difficult. Okay, so we've got our reminder, which is k, but this part is not correct. This is not 0, but this will be like remainder div index as I32. That could be 0 at some point if you do 1 divided by 2. And this part will be I guess not this, but a reminder modulo index. The mod part will go yeah, this is quite insane, to be honest, but now it works. So it's Interesting. Wait, how does it work? No, it looks like it doesn't work. We have some scenarios where this part doesn't work. Okay, so let's go 1 to third one. This one doesn't work. So here we've got like 4. Yeah, let's check. Let's debug it a little bit. So we've got reminder k being 0, that's fine. Remainder it's 1. So this wait. Okay, so remainder index. So this what did it become? Man, I didn't check. One divided by 1 will be 1, but that's not correct. So that's not right. But how this is 1? Wait, 1 should be like 2. Yeah, let me get back. So first value it's 0. Then value it's 4. Do I check the right one? Oh, okay, so 0, 4, 2. Okay, got it. Okay, so index being 1, value being 4. So this goes negative. We have a reminder being 1. But wait a second, because in this case, the index, so I'm a bit confused. Because this 1. Okay, so in this case, that's correct. But modular part, it's not correct because this is 1. That's correct. This should be 1. But to reminder modulo index, this should be 0, y plus 1. No. If reminder modulo index as I32 greater than 0, we do this. Because if it's 0, we shouldn't move anything. We already removed that part. Okay, so now this works. Let's check the other scenarios. So all 4 works. We then copy this part and try to run it again in LeetCode. Yeah, unfortunately I need to use std collections map run. and submit. Oh, so we've got a big one. Yeah, I feel like now we need to get back to our value here. To put it 10,000, not like 1,000. Oh my god, so we did it, guys. We did it. And not we only did it, but we have the fastest solution. So that's we beat 100%. So we spent like an hour and a half, but we do have a very fast solution. Not necessarily on the RAM side, but we beat everyone else. So pretty cool. Awesome. Yeah, okay, so we solved this problem. So we have like a 52 days streak. This means like for 52 days in a row, Sundays, Mondays, I am solving LeetCode problems from easy to hard to all other possibilities. So nice. Okay, so we solved this one. We'll get back to our session on trying to solve the bit manipulation ones, where we try to look before. So let's check again. Yes, sorry for the white part. Yeah, so we increased our medium solved problems by 1. Yeah, let's find. So difficulty will be easy. Tags will be bit manipulation. And acceptance, descending order. So we go one by one and we are close to finish everything. We are very close. Attempted. So I've attempted to work at this one, but I didn't finish. Okay. Number complement. Okay, so the complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to zeros in its binary representation. For example, the integer 5 is 101 in binary and its complement is 010, which is the integer 2. Given the integer num, return its complement. So we'll need to invert everything. So I need to output 2. Cool. Yeah, that's an interesting one, an interesting problem to solve. I'll have a refill. I kind of do not have water anymore, so I'll be back in just a minute. Okay, so I'm back. I'm back. Find complement or invert everything. How can we invert everything? If we try to invert everything, let's try to go on our whiteboard. Yeah, let's use a new canvas. So we kind of have, let's assume we have 5. So 5 will be 1, 0, 1 in binary form. It may be 0 here, but where depends on the type. But this will be 5. Inverted, this will be like a 0, 1, 0, which will be equal to 2 in this case. But how can we invert it? How can we invert each bit? So maybe we will need to set okay, so we know if we go with an algorithm something like okay, so we'll be shifting right 1 bit. So it'll be shifting right 1 bit. So assuming now we'll have the last bit 1, index being 0. We can invert it, it'll be 0. We can set bit position 0 to being 0. We shift again. So when we will be shifting this number, it will be like 1, 0, because we shifted 1 right. Last bit will be in this. We will invert it being 1, but in this case, index will be 1 already. So we'll be set bit position 1 being 1. We move 1. We have last one. We shift right once more, and last one will be 1. Became 0. And we don't even need to set it because it's already set, if I'm not mistaken. Yeah, okay, so first thing which we'll need to do, yeah, let me clean this up. It's how to set a specific bit. Yeah, let's try to do a little bit of research. Rust. Rotate left, rotate right. Toggle set, so original mask. Shift free, false. Yeah, this is not helpful. Yeah, let's check this part. Setting a bit, setting 5th bit. Okay, so we can start, yeah, that's a cool one. So we can start with a result, a complement being this number. So yeah, we may try to code it this way. Yeah, let me zoom it for you guys to see. I don't know if there is a dark background. Inspect. Yeah, maybe we can set up fast a dark background to be able to view it. Yeah. Okay. Probably will go this way. So the idea is we can set the 5th bit. So we know what bit is, and we can try to set only specific ones. So this will be our starting point. Not sure I did it. Yeah, kind of. I didn't do it right. No, I did not copy the right thing. Wait, actually we can toggle bits. So maybe we can do it this way. Hi, new here. Hello, hello. Yeah. New shout out to Vibe Have Tree Party. Vibe Have Tree Party. Yeah, welcome aboard. Welcome. Toggle bits, clear bits, set bits. I'm feeling we may try to toggle bits though. That's a little bit cooler. So, but we need to toggle all bits. How can we do that? I don't want to toggle the 4th. I want to toggle all of them. So if I assume this will be A, like num. I'm gonna try like num. Num. Oh, thank you. Yeah, that's really, really good to hear. I mean, I like when someone watches. I mean, I do not have like tons of viewers, but little amount of viewers I have, if they tell me such good feedback, I'm glad. So thank you. So I just try to learn myself a thing or two, and at the same time do a stream and teach something. So because by teaching you will also learn, so that's a good thing. Yeah. One thing though, what we want to try is this stuff, which is a little bit insane. But I can try to do something like this for range, probably range being 0, 32. Yeah, I'm not sure how, because I didn't kind of request that, but I have a lot of viewers from India. So probably you guys are into algorithms and math and technical stuff. So if I look at the stats on my stream, it's a lot of people from India watching, which it's quite good. I mean, I don't mind. So at least people enjoy. Like people from my country, where I'm from, they do not watch it, but you guys are watching it, so feeling good about that. Yeah. So in the end, we'll try to return num, which is a pretty cool solution if that will work. But it will not work. It's immutable. Okay, so yeah, for sure. And I know a couple of guys. Yeah, actually, at my current job, I do work with people, but they're not actually from India. They are from Pakistan. But I don't want to say that it's the same, but you are closely related somehow. I mean, I know that politically and ideologically, Pakistan and India are completely different stuff, but you have some relation for sure. Maybe a little bit cultural part. I'm from Republic of Moldova. So Eastern Europe, we are neighboring Ukraine, unfortunately, with all this war stuff. Yeah. Okay. So this is not a good approach because I'm toggling too much, though. I'm toggling too much. I do not need to toggle as much. I just need to shift right till. Okay, so I kind of understood now. So let me do a copy of this number. So we'll be shifting right the copy while copy greater than 0, or actually greater or equal to 0. No, greater than 0, because it should exit. Yeah. What I noticed that they have some sort of anger towards India, guys from Pakistan, but I do not know the history. I mean, probably at some point India took something from Pakistan and yeah, okay. So our Indian army took care of them. Yeah, I do not know the whole history on this subject, so not an expert. But what I can see, so yeah, what I'm telling that those guys are very good. I mean, good in algorithms and stuff. So you have something on your DNA at your DNA level. Okay, so we'll be shifting right our copy by 1. Copy shift right. Let's do copy equal this. Will it work like that? And do this. So we'll be let mutable index 0 or bit. Let's call it bit. So let's toggle this bit and bit plus equal 1. No, they are not working. They are not actually working in my country. We are working remotely. I'm working for a remote company. So they're working from Pakistan. I'm working from Moldova. So it's a remote company. So everyone works from their homes. Awesome. So looks like we've got somewhere. Can we reduce a little bit? Okay, got it. So yeah, let's try this solution. Okay, it did work. Can we improve it a little bit? The idea here, we kind of need to copy this, mutate. Oh, okay, wherever. So yeah. If you need some explanation what's going on here, so main point is like I'm shifting right to count how many bits there are, and with this line I'm inversing them. So this is an XOR operation with 1 at a specific bit position. So that's a cool trick. So yeah, we solved this one. Let's move on. Missing number. Yeah, let's try this. Given an array nums containing n distinct numbers in the range 0, n, return the only number in the range that is missing from the array. Okay, so we given an array nums containing n distinct numbers in the range 0, n. Return the only number in the range that is missing from the array. So we have the array, but we do not know the order. That's an interesting one. And distinct numbers in the range. Okay, so when they give us is it a size? Because I'm a little bit confused. How can we identify the range? GEE GEE advanced. Google it. Yeah, let me try. I'm not sure what's that. Advanced. Exam will be held on Sunday. So what's this? Joint entrance examination. Okay, so there is an Institute of Technology, and in order to get in, you'll need to pass an exam. That's the idea. Okay, interesting. Yeah, let's check. Yes, G Advanced is undoubtedly a tough exam due to factors like increased competition, challenging syllabus, limited attempts, and lack of authentic preparation resources. Well, the exam largely covers the same subjects as GE Main. The difference is not only the weightage of the marks. Okay. So, do you want to participate? Do you want to get in? Yeah, one thing which I can tell for sure, the amount of information which is on the net, like books, courses, it's at insane level right now. So I would decrease a little bit on the value of these universities to some extent. But on the other hand, what you will gain undoubtedly if you'll get in, it's like same peers which are pretty strong engineers, very strong engineers, future engineers. So you'll have like connections with very good strong guys. So this is the value which you'll be getting. I'm pretty sure there is nothing there which they teach that you will not find anywhere else. But the people around which you will gain, like your future colleagues, this will be your gold. I mean, the main value of that university will be from the peers around. So they sift like the best ones, and that's a very, very good thing. Yeah, for sure. I mean, if they select the best, it's that's the tricky part. So if you select only the best people, like the best qualities, fast thinkers, the ones who learn a ton, most ambitious ones, for sure they will produce more than other. So nothing strong here. So they gain a ton by creating like tough rules. But if you get in, you'll have a lot of value by having like very, very good friends, hopefully, if you'll manage to get in. So yeah, try your best. And do not forget what this university will teach you. Okay, so looks like that part. Yeah, thank you for the compliment. I have my bad days though, so like anyone else. I will not tell that I'm good, but I try to help. I mean, that's innate good thing. So if we try to get back to this problem, we're given a range and we need to identify the missing one. So if you try like a simple approach, we can sort this array and then go number by number and try to figure out which one is missing. That would be a solution. Yeah, for sure. I mean, studies are tough, and if you want to get into tech, unfortunately, they will never end. So, but I recall my exams. They were also, some of them were pretty tough. Yeah, stress is vital for our body. So if you don't exercise, you don't put stress or pressure on your body, you'll get into some liquid form. You lose your human form. Same with the mind and other things. So you need stress to thrive. Yeah, how can we do that in one go though? And this is marked as a bit manipulation problem. But I think they marked everything. So hash table, math, binary search, bit manipulation. I think that's misleading. I guess by using like this, by using this constraints, n equal nums length, and it's this number 10,000 nums I. Okay, so I guess the solution here would be to do some sort of bucket sorting, but my idea will be something on those lines because we know they're distinct and there is a specific range. So let's assume we're given this number 301. Yeah, one thing though I don't understand is, okay, so n will be equal num len. So this is clear. So okay, so if we got 3 elements, oh my god, yeah, for sure. I mean, man, I'll be streaming from time to time. So if you mark the bell button, you'll have a notification. So when I'm streaming, we can continue our discussion. So yeah, thank you for joining in. So thank you. Yeah, bye bye. It's too late for you. Yeah, bye bye. I'll ban you if you do not disconnect. So go sleep. Yeah, see you. Bye bye. Not sure how to ban though. So that's tricky. So this is free. Got it. So my idea is if I have an array with range 3, I can create an empty array with 4 values, 4 indexes. And wherever I have a value, like 3 for example, exists, I'll mark it with 1. Yeah, thank you. I don't necessarily want to be the best anything. I just want to enjoy life and be useful and have a good time. So yeah, how can I do it? Yeah, love from Moldova. So yeah, here I plan the following. I have a 1 here, so I'll be changing this to 1, and I have a 0, and I'll change this to 1. So the single element missing will be the index 2, where actually it's 0, 1, yeah, 2. So this index. So this will be our value. So yeah, let's code it. It's quite easy problem, and I think it's marked as easy. So let's do the following: nums iterator fold. Let's create a back 0 nums len. Yeah, teach and inspire. That is a thing which I would like. Okay, so go sleep. Yeah, it's enough for today. For you. I'll not talk to you anymore. So bye bye. accumulator item +1 will be returning this. Can I do it in one go? Extra space. Yeah, they asked us to not use any extra space. This means we kind of need to use the memory given. Because I'm trying to use extra space with this part. Nine. Yeah, let's try first without extra space, and then we'll try to do with extra space first, and after let's try without. Okay, so we've got this. Let's call it a sequence. So we've got our sequence. Okay, so we've got our sequence. And next stage, we need to find the 0. Sequence, iterator, enumerate, find x, but in our case will be like index, find the index probably. Find the index. I don't know if there is such a function. Rust. Oh, it's called position. Okay, position works for me. And we don't need to enumerate. So position and and we check n being equal to 0. And I assume this will need to do reference. Let position. Let's return this position as I32. And we need to unwrap it. Yeah, we don't need this. Yeah, so we have a runtime error. Which is a little bit unfortunate. Unwrap word default. Oh, good question. So you can write comment or Twitter. So email, or actually my blog. So you can check Twitter will be the hashtag email or blog, and the blog part let me show you. Here, contact. So YouTube, Facebook, LinkedIn, Twitter, Reddit, GitHub, Stack Overflow. Yeah, I do. You may try to phone me if you want. Twitter, direct messages, if you can write YouTube, this will also work. So this is my blog, so I don't have as much content, but one day I'll publish a little bit more. When I'll solve my laziness problems. I'll try to. But I spoke with a couple of Indian guys, so in my head they may. I'll try to attach your name with this GEE stuff. Future GEE student. Vibe half. Yeah, let me see what's up with this code, because I'm not sure why it doesn't work. Okay. Yeah, I have okay, so we had some problems which we solved during previous streams. Yeah, let's create another one. What we're trying to do. Yeah, we're trying to find the missing number. Where is it? Yeah, this one. So let's copy this part. Let's add some tests. Super. Let's add a couple of scenarios. So let's add one at least. And we're missing two. Sorry, but I don't need Copilot now. Okay, okay, the len is free, but the index is free. Where, what? Oh, so we need to allocate one more. That's the idea. Okay, yeah, that was the trouble. So instead of allocating like exactly 3, we need to allocate one more because it's missing. We need to find it. So yeah, do you want me to check it now? Okay, so let's submit. I'll check a little bit later after the stream. Okay, so we managed to solve it. Though we used extra space, so we used an extra sequence pod, which is extra. So it's not linear. It's not O of 1. Runtime, it's O of n, so time complexity, it's O of n, though we use extra space. Let's think a bit, how can we reuse initial array? Maybe, yeah, maybe it's the same approach. Let's assume we got here 3. Yeah, let's try to go to brainstorm a bit on the drawing board and try to use the same approach. So we have the assumption like 3, 0, and 1. So we need to pass it once. We need to pass it only once. Oh. Oh. Maybe we can have a bit which starts at 0, and every time we find any value in the range, we'll be increasing it to 1. Okay, so we'll be increasing that bit to 1. And at some point, we'll just shift right 1 by 1. And we'll get a 0, the one which is not set. Shift. And in that case, we'll have our value. So this that index will be set. So yeah, actually we don't need any extra. Oh yeah, that's a genius. I'm a genius. Sometimes. Very rarely. So we'll have a bit where a mask. Let's call it mask maybe. That will be clearer. So it's 0 at first. So we traverse our array. So this will be like nums, iterator. I guess I can go with the for loop. I don't need anything extra, so let mutable for a bit in nums, we can call it this way, mask. Yeah, now I need to recall how we toggle a specific bit. I think it's this 1 and bit. If I'm not mistaken, I think that's the way to go. And we can try to print it. So we can try to print the value. So let's try to print the mask. For now, I just want to check the result. Let's check what does it do. It's just 1. I think it's like that. It's binary. How can I create a bigger one? No, I mean the idea it's probably good, but now I need to figure out the implementation. So, but this will not toggle. This will toggle, but I don't need to toggle. I need to set. Yeah, and I did it in the previous problem. So yeah, need again to have so set a bit in Rust. Okay, so we can do this. U8. That's pretty cool. Clear bit, toggle bit. I don't need to toggle. I need to set. Okay, so we use or. Or, yeah, that's right. So similar concept, but it's not XOR, but just OR. And here we can do this. Can try to do this. Again, 0xff. For I32. So that would be the mask. We'll be setting stuff. No, this doesn't look right at all. Let's start with 0. Run test. Became 1. Unsigned. But we know that that's a positive range, so let's go with the U32. Because mask U32. Let's try this. Yeah, but how everything is set, that's yeah, let me print before. This is interesting. Wait, it was so it looks like that's not right. F, but we don't need to be F. It should be like this, I guess. So 0 became 1. It's not right. Mask. How to write this code though? Yeah, let's debug it and try to see what does it do. So I have mask 0. I'm setting the bit, third bit. Mask becomes 0 again. It's not right. Yeah, we need a bigger. Yeah, let's research. I don't know how to do it. Yeah, that would be 0, setting the 5th bit. And this doesn't work though. That's the trick. Zero 8B. Oh. 0 8. So maybe that's the way to go. Okay, so that's a different 0 now. If you go with I32, it's 032, I guess. What's... Yeah, okay, so this is the right stuff. But we may have a bigger bit, so it's not correct. Yeah, this approach will not work, because we may have only like 32, maybe 64 bits set, but we have a range of 10,000s. So I cannot set like the 10,000s bit. That's too much memory. Yeah, so my genius is not that genius. So this doesn't work. Yeah, let's see, maybe there is some solution already. Because the goal is to learn first, and then I think we submitted already, yeah, and it did work. Oh, and it's the fastest. Oh, that's a math solution. That's a cool one. So it's n multiplied by n plus 1 divided by 2 minus sum. So yeah, that's a smart one. So we do a sum. Yeah, that's a really, really smart one. We sum everything because we know it's a sequence, so we use this cool trick to find the sum of pairs. So we multiply the first item plus 1 divided by 2 by the amount of how many pairs, and this will give us the sum. And then we'll just sum all the numbers from the vector, and the remainder will be our missing number. So that's really, really smart. Yeah, that's genius. What I planned is not genius. This stuff which I wrote also, it's not necessarily very bad, but that one, it's orders of magnitude better. So abort mission of being a genius, because I'm not. But at least I try to learn a thing or two. Yeah, let's move on. We are closing the gap on solving them, but it's a little bit late. So let's check out this problem. If it will be something cool, easy. Oh, this is a binary problem. How did you get to count nodes? Okay, so the value of the nodes, the number of nodes in this free range, so 50,000 nodes. Okay. Looks like something wrong with my... Okay, so now we fix that. Given the root of a complete binary tree, how this is bit manipulation related? Oh, it's not. Binary search, bit manipulation, and binary tree. That's for sure is misleading. According to Wikipedia, every level except possibly the last is completely filled in a complete binary tree, and all nodes in the last level are as far left as possible. It can have between 1 and 2 power h nodes, inclusive at the last level h. Design an algorithm that runs in less than O of n time complexity. Count complete tree nodes. Wait a second, I'm not sure, so I'll put 6. Okay. So I guess to have to count the nodes, we need to do a breadth first search. A depth first search in DFS, so that would do it. That would solve our problem. But let's see. No, but they will be only complete. Or will they? Yeah, let's get back. Yeah, let's get back to this. So do they want me to write a DFS and that should solve it? Yeah, what's given? It's 1 and 2 H nodes inclusive at the last level H. It is complete. Okay, so we don't need to find if it's complete or not. Return the root of a complete binary tree. So how can we do it in less than n of n? I guess we can we may check if they have values or not, and like to not go to the last step. Okay, so let's go on the drawing board and try to figure it out there. Because a way, yeah. Okay, so let's pick some normal color. Yeah, let's pick this one. So we have the following binary tree. Yeah, let me copy this one. 1, 2, 3, 4, 5, 6. Okay, so it will be 1, 2, 3, 4, 5, and 6. So if we go with a depth first search traversal, we're given the root. So we can have like the increment 1, we know it's one node. Then we go recursively. But actually we can go breadth first search. We can go this way. And then we'll increase by 1, then by 1, by 1, and then go I guess it will be, so if you put 1, 2 and 3, then yeah, 2 will be first, then we'll have like 4, then 5 and 6. But still we'll be visiting all nodes, so that will be big O of n, not less than that. So what do they mean when it's not to not visit the leaves? But how do we know it's a leaf or not? So probably a way to optimize it would be to get to 2 and 3 and not necessarily visit the next part. But how do we know it's the last without entering there and looking at the value? So we'll need to enter in 4 and see that it doesn't have anything. So it's none here and none here. That we cannot move further. Yeah, that's not easy for me. I mean, I do not see it in less than O of n time complexity. Yeah, let's try to write at least to be big O of n complexity. Because this will be like a traversal, graph traversal. Yeah, so let me go back. This kind of needs to be reverted. This doesn't work. +1 here. Okay, so I'm thinking I'll end now because you'll not go to sleep. So yeah. We'll end it now for the sake of one viewer which doesn't want to go to sleep. So yeah, let's finish it. I'll think of this problem and how to solve it in less than big O of n. Because the simplest way is just we need to write a BFS or DFS or wherever, doesn't matter in this case, and count how many nodes we visited. So every time we visit a new node, we just increment the count number, and in the end we just show. So that should be it. Okay, so yeah, thank you guys for watching in, and that's it for today. It's a pretty long one, 2 hours and a half. I'll do another stream, I guess, during the weekend, probably on Sunday. So yeah, wish everyone, including Vibe Hub, good night and sleep tight, everyone. So bye bye. See you on Sunday. Bye bye.